Good morning. Today I'm going to show you a part 3 in my case project. This is I'm slightly proud of this one because this one demonstrates filleted corners for these posts, which strengthens them to against the base. So what I have pictured here is 4 posts in their final position for supporting an Arduino, and they're lined up with the Arduino holes. One of the annoying things to me about Arduino holes is they're all completely different, except for 2 and 3 I think are lined up on the y-axis, but every other one is different. So we're going to be adding these to the base that we created earlier. Now you'll notice this base has been modified a little bit, and I'll get into that. This isn't its final version, but it's just large enough to hold these Arduino holes. So this is the finished code, but let's start from scratch. So let's open a new OpenSCAD project. And what we're going to be doing is, the first thing is we're going to be creating the shape for the fillet. And this is going to be using a square of radius 5. Actually, I think it's going to be a smaller radius, but we'll start with that anyway. And we're going to be using a circle, and that's going to be radiused at 1.5. And those two represent what the outer portion of the so it is. I think it is going to be 2. The outer portion of the post will end up being. So I've just added the face fragment number, yeah, made that 50 so it looks a little prettier. Let's zoom up. Okay, so with the scroll wheel, and so the first thing we're going to do is we're going to center this square, and you'll see why in a second. It'll become really obvious. And now to get our fillet shape, we're going to difference these. And I highlight this and hit tab to move them both over and end the parenthesis, and show you the difference. Oops, it's not quite the difference I was going for. Oh yeah, I still have to move the circle. So we're going to translate this over to the radius of the circle, because I want this to just take out one little corner of the square. And that should do it. Nope, what am I missing there? Circle translate. Oh, my end parentheses. Always forget those non-trivial things. All right, so you see that's just taking out the chunk that we want. But what we're looking for is this shape, not this whole shape. So we just need to I just need to leave this behind, and we're going to do that by creating another square with the measurements of 5 and not centering it. And that's the easiest way to get these 2 squares, one with the corner at the origin point of the other. So you always like to minimize typing. So now to get that, just the remaining piece of the fillet that we want, we're going to do an intersection. So the intersection will just leave the bits that are let's tab this over so it's well formatted. The intersection will just leave the bits that are touching. So that's the basic shape for our fillet. Now remember, because we're doing a square and translate, this width is just to make it easier to see the object. It's really just a plane. There's no height yet. So we're not going to need height. The next thing we're going to do is we're going to extrude this, and so that it's going to be extruded around the z-axis. So before we extrude it, we need to get it into the right orientation, and we're going to do that by translating this whole structure, and it's going to get translated. You just have to push it out on the x-axis by 2.5. and nothing on a Y, nothing on a Z. And then we're going to bracket the whole structure here. And let's tab it over so it looks nice. Tab that over. Okay, so oops. I want to include the entire thing, not just the good. So same number of brackets. And let's rework our prettification. Okay, so that's where OpenSCAD uses this distance as the rotation by default as for the rotational extrude. So it'll extrude around the z-axis at this distance. So now to do the extrude, you just simply add rotate extrude and convexivity of 10. And we actually don't need to bracket that. Okay, so that's how we get our fillet. It's not terribly that difficult. It's certainly not clicking a line and clicking fillet 2 clicks like in FreeCAD. But it helps you understand what's going on, and it's not that hard. I've seen some other tutorials that show mathematically derived fillets, and I don't think it has to be that hard. I think it can be just this easy. So the next thing we're going to do for the post is add a cylinder. The cylinder is going to make up the post. It's going to be of 2 pieces. It's going to be 2 cylinders basically, one inside the other and then differenced. So let's add the first cylinder, and its radius is going to be 2.5. So we're going to define radius with R, and we're going to make it a height of 10. That's something that'll change later on when we're actually putting it into the case, but it's good for now. And then the second cylinder, let's copy that, is going to be so this is the radius for the screw hole. The screws are 3 millimeters, so we're going to do a radius of 1.5. Now we're going to make this cylinder 2 units larger because it's going to be differenced out from the first one. So if we do that, we see we've added the cylinder and we've added what's going to be the hole. Now you could actually just leave this and mount the Arduino on top of it and have some kind of capture thing, which I think I might do as an alternate path to this tutorial, because I think that'd be a neat thing where the Arduino just snaps on this and the case snaps on top, so it's a screwless case. But for this one I'm going to do screws. So I'm going to translate this down by 1 on the z-axis so that we can difference it. So you see that's moved down, and now when I implement difference, the screw will be removed, and it's removed all the way through in this case. And that's what I want, because I want it to be able to receive multiple lengths of screw and not bottom out halfway or something like that. So that's our post. Not too difficult, I would say. So the next thing we're going to do is create 3 more posts, and they're going to be in position, in the positions the Arduino needs them. So the next thing I'm going to do before I create the structures, I'm going to turn this into a module. And the reason is I can just leave this down below without kind of out of the way, so I can visually focus on the other pieces. And if you created parameters in this, it might be able to become something that you can use easily in other things. So I'm even going to just send that all the way down. So now it should disappear. Yep. So now when I add it back, just by the module, and this is for testing, that's back. Okay. So now that I've created the module, let me add the first. Let's position this in the first position necessary. So all I need to do is add a translate for this. I am not the best typist. I actually have to look at the keys while I type. So I've measured the positions, and let me show you that real quick before I go forward. I measured the positions in FreeCAD, and what I did was I took an existing step file of someone who had done an Arduino. I'll try to include the name if I can figure it out. I download these things and then lose the name. So the model looks like this. It's a beautiful basic model. I can't vouch for the accuracy of the dimensions, but we're going to use them in this case because this is just a tutorial. So you see, it's a nice basic model, not too overly complicated. There's some that are even better, that have every single detail of the Arduino. So I created with FreeCAD. I created a orthographic projection onto a drawing page and added dimensions, which I'll do this another video on this because I like this. I think this is great. I could model basically cases or whatever for an Arduino without actually having one or having ever bought one, because these files are available online. I've looked at dimension drawings, and they're always missing something you need. So doing it this way, you can measure whatever you need to measure. Later on, I'll be measuring, the cutouts for the pin headers. So what I'll be doing is taking each of these dimensions and putting them into FreeCAD. So we're putting them in OpenSCAD, by the way. So let's go back to our drawing here. So the first dimension was on the x-axis 1397 and by to 254 and no z. So that moves that out where we want it. Now this is good, but I like to have this abstracted so it's all in one place, a little bit easier to see. Because what I'm going to add is I'm going to add a numbering system for this using text strings. So it's easier for me to know what object I'm working on. And whereas you can't highlight in OpenSCAD, it's a good way. This is a good way to identify what you're working on. So I'm going to have a string next to each one. Now the problem with that is once you start adding stuff in between, your measurements get lost, and that's why setting up parameters is really useful. Whereas I'm not going to go to parameters. What I'm going to do is I'm going to set up an array of measurements. So for the first post, we're going to set up a vector variable, and it's going to be the same measurements from down here, but just in this vector. And we're going to change this, and I'm also doing this to show that you can do it. So that's going to be post 1. You'll notice I just hit F5 and there's no change. Okay, so now I want to keep this text right next to it. So I want to put post 1. So to translate the text and keep it right next to it. Oops, that's not where I want it. Well, it's because it's the origin of the text went there, and we don't really want it there. So now I'm going to create an offset vector, and that offset, it's going to be -10 in the x direction, and it's going to be -5 in the y direction, and nothing in the z direction. And then what we're going to do is just add these two vectors together to get it positioned where we want it. And that's good. It'd be nice if it was a tiny bit over. Let's do offsets. Let's do offset 11. Good. Yeah. Anyway, so that's not the part of the tutorial we're terribly worried about. So now we're gonna do the same thing, but for the rest of the posts. So let me copy this down. So it's going to be post 2, post 3, post 4, and the measurements are 66.8.04, 7.62, 0. The only one that lines up, 66.04, 35.0. 6 and 0. And then the last one is at 6.35 on the X and 49.53 on the Y, 0. So basically I set up, you know, I did just X, Y coordinates starting from the 0, 0 origin, just to kind of make it a little bit more, a little easier to understand. So now you start to see a little bit of the beauty of it, of using variables is, I'm just going to go through and change all these to the correct numbers, and you see it's a little easier to navigate through your code when you don't have the minutia, and the minutia is abstracted. Anyway, okay, so 3 and 4, and let's see if I got it all right, and I did. So that's exactly where our posts need to be based on our Arduino drawing. So the next step will be just to put this code in place for our with our existing case. Fortunately, I have gotten that started in my other design that I showed you in the beginning, so we're going to go over to that. And so what you see is I have a project box that I've made fit the Arduino dimensions a little more. It's taller than what you've seen in the previous tutorial, and its width and length are set more correctly. So at this point, all we have to do is move the Arduino case, the very corner of it, from 0, 0, or the posts, if you think of the origin as here, from 0, 0, 0, from its 0, 0, 0 to you know, into the case somewhat. For me, the easier way to do this is to set up a module for filleted posts. So what I've done is I've done that. Created module filleted posts, and that's all the work we've done before. The screw mount, all the settings, the offsets. I have offset 15 here, and then just you put that in filleted posts. So right here I have it offset to 40 so you can see it. Let's move it back to its origin there, but you can see it's not exactly where we want it. Now, because I measured off the X, I used the 0, 0 as the origin for these measurements out of FreeCAD. I know I have to move it from 0, 0, 0 to this corner. So that corner is easy to determine. It's half of these, length and width. So okay, I took a little break there, and now let's add this final piece to get to where we're gonna. So I'm showing you what it looks like, but you'll notice the translate command is missing because I want to type that in and show you one piece at a time. So if I redraw it, it's at 0, 0, 0. And what I accurately dimensioned our Arduino based on our other drawing, and you can see, so it's our Arduino its length is 53.54. That's this y-axis, and its width is 68.58. Sorry if I'm using length and width incorrectly, but I vacillate on which should be where and what, and maybe should use depth, and I don't know. Maybe I should say it's X length, or but you know what, if you're viewing it like this, so sorry about that. If there's some kind of standard that somebody knows about, I'd love to know what it is. So we're going to translate these filleted posts to basically half the height and half the width. So to make it easier to read, I always do that. I do one line for each dimension when I'm using variables, because it just gets ugly to me otherwise. So it's width divided by 2, and then it's going to be length divided by 2, and then we're going to be moving it in the negative direction, because that orients better to our box. And the reason I do it this way, there might be a better way, I'm not sure, but you know, when I constructed this box, it was all centered around 0, 0, 0, and I find in my experience so far, which I admit is not significant, I just find that things that are centered are easier to predict where they end up, and if they're not centered, they end up places where I don't expect them. So that's the final. That should do it. All right. So now we've got our posts in where we need them, and one thing you'll notice is I like it because it's touching that, and it's going to be or not quite touching it, I guess, but there'll be very little play in that. This probably won't work. These walls are probably, oh, it definitely won't work. These walls are going to be smaller than the Arduino, so let's just add, we'll leave that for now. We'll fix that in the next lesson. So what you'll notice is that these are sticking out. Now what we could do is, I'm not going to in this one, but we could just do the intersection of the posts and the case, and that will get rid of, you know, the pieces that are sticking out. But I'm going to leave that for now. This is already getting pretty long, so I didn't want to make it any longer. Thanks. If you liked this video, sorry it was so long, click on the like, please subscribe, and click the alarm bell if you want to be notified. Thanks again. Have a great day.